Hey guys, welcome back to the episode 5 of the series on circles. In the last episode, we have discussed the concept of intersection of circles and we have derived the expressions for the length of direct common tangent and transverse common tangent to two non-intersecting circles. Alright, now in this video, which is episode 5 of your series, we are going to solve 3 questions based on the intersection of circles. We'll start with an easy problem and we'll solve a difficult problem, two difficult problems, one of which actually appeared in JEE examination. Alright, so let us go ahead. So the first question goes like this. Find the condition if circles whose equations are, this is one equation and this is another equation, touch one another externally. So we have discussed it in the past video. So we have discussed it in episode 4. If you want to know the condition for which the two circles touch each other externally, you can always go back to the 4th episode and check it out. So this is how the circles will look if they are touching each other externally. So if you join the centers, so this will be R1 and this will be R2. Let us say this is center C1, then center C2. The condition for the circles to touch each other externally is that the distance between the centers is equal to the sum of the radii. Alright, so now let us use this condition. Now let us use this condition to solve the problem. So the first circle is x square plus y square minus 2ax plus c square is equal to 0. So the center of the first circle is simply a comma 0 and the radius of the first circle is simply square root of a square minus c square. Alright, let us look at the second circle. X square plus y square minus 2by plus c square is equal to 0. So here the center is 0 comma b and the radius r2 is simply b square minus c square. Alright, now we have this particular condition. So what is C1, C2? C1, C2 is the distance between the centers. You can use the distance formula here. So if you do that, you will get square root of a square plus b square. And the radius r1 is a square minus c square. The radius r2 square root of b square minus c square. Alright, now square it on both sides. So you'll get a square plus b square is equals to a square minus c square plus b square minus c square plus 2 into square root of a square minus c square multiplied by b square minus c square. Now this a square will get cancelled, b square and b square. So this will be simply 2c square is equal to 2 into square root of a square minus c square square root of b square minus c square. 2 and 2 will get cancelled. Now square it on both sides again. You'll get c power 4 is equal to a square minus c square multiplied by b square minus c square. So this is simply a square b square minus a square c square minus b square c square plus c to the power 4. So this and this gets cancelled. Now bring the negative terms to one side and positive terms to other side. So you'll get this. Alright, now c square is common here. A square plus b square is equals to a square b square. Now so a square plus b square upon a square b square is 1 by c square. You can rearrange the terms and write it like this. Now if you split this denominator, you'll get 1 by a square plus 1 by b square is equal to 1 by c square. So this is the condition for which these two circles touch one another externally. I hope you're clear with the problem. Now let us proceed to the second question. So what is your second question? I'll explain the problem first. So these are two circles. Alright, they touch each other externally at this particular point and this is the direct common tangent for these two circles. The radius of the circle C1 is R1, radius of circle C2 is R2. Now what we are doing is we are drawing a circle in such a way that it touches this circle externally at this point, and this circle externally at this point, and this direct common tangent at this particular point. Now I want you guys to find out the radius of this particular small circle in terms of r1 and r2. All right, so this is the question. All right, so let us go ahead and solve. I'll zoom it out a bit. So now what we can do is, let us say this is the center of the first circle. Let us say this is the center of the first circle, O1, and this is the center of second circle, O2, and this is the center of this circle, smaller circle, O. All right, now you can draw a perpendicular onto this direct common tangent, and this will be simply radius r1. Similarly, this will be simply radius r2. So this is a very famous problem. Everyone who is preparing for Olympiads will know this problem by heart. They know this result by heart. All right, and it is very important for JEE as well, and you might even see it in one of your part tests, grand tests, whatever. So now let us assume the radius of the circle is r. The smaller circle radius is r. Now what we will do is, I'll join these 2 points, and I'll join these 2 points. Now OO1 is simply r1 plus r, and similarly OO2 is simply r2 plus r. All right, and let us draw a line parallel to the direct common tangent here. All right, so now this particular length will be r1 minus r, and this particular length is r2 minus r. All right, now what we can do is, so consider this particular right angle triangle. If you apply Pythagoras theorem here, you will get, let us say this point is A and this point is B. If you apply Pythagoras theorem in this particular triangle, you will get AO square plus AO1 square is equals to OO1 square. So AO square is equal to AO1 square. AO1 square is simply R1 plus R1 minus R whole square is equal to OO1 square is R1 plus R whole square. Similarly, apply Pythagoras theorem in this particular triangle. Then you will get OB square plus O2B square is equal to OO2 square. OB square plus O2B square is simply R2 minus R whole square is equal to OO2 square is R2 plus R whole square. Alright, now let us solve these equations a bit. AO square is equal to R1 plus R whole square minus R1 minus R whole square. This is simply R1 square plus R square plus 2R1R minus R1 square minus R square plus 2R1R. So this and this, these terms will get cancelled. So it is simply 4R1R. AO square is 4R1R. Similarly, if you solve this, you will get OB square is 4R2R. Alright. So we got AO and OB. Now AO plus OB. What is AO plus OB? AO plus OB is 2 times square root of R1R plus 2 times square root of R2R. But your AO plus OB is simply the length of the direct common tangent. Alright, this is the direct common tangent. So what is the formula for length of direct common tangent? So that is square root of the distance between centers, O1, O2, that will be simply R1 plus R2, R1 plus R2 whole square minus the difference of radii of two circles, square of difference of radii of two circles. Let's say R1 is the biggest here. So R1 minus R2 whole square. So we have discussed it in the previous episode. Alright. So this is the length of the direct common tangent. So D is the distance between the centers and R1 minus R2 is the difference of angles, difference of radii. Alright. In this case, we know the distance. So distance is simply, distance between the centers is simply R1 plus R2 whole square. So now we will get this is equal to 2 square root of R1R plus 2 square root of R2R. Now let us simplify this. This is simply root of R1 square plus R2 square plus 2R1R2 minus R1 square minus R2 square plus 2R1R2. So this is simply 2 square root R1R plus 2 square root R2R. So all these terms will get cancelled. So this is simply 4R1R2 is equal to 2 square root R1R plus 2 square root R2R. So this is simply 2 square root R1R2 is equal to 2 square root R1R plus 2 root of R2R. This 2 gets cancelled. Now we have to express R. So this is root of R1 R2 is equal to square root of R is common, square root of R1 plus square root of R2. Now you can rearrange this and write it like this. 1 by square root of R is square root of R1 plus square root of R2 divided by root of R1 R2. If you split the denominator here, you'll get 1 by root R is equal to 1 by root R1 plus 1 by root R2. Many students who prepare for Olympiad and JEE, they know this result by heart. So your R is the radius of this smaller circle and it can be expressed in terms of R1 and R2 by this particular formula. Alright. So this is a very classic question that everyone must know how to solve. And by solving this question, you'll get to learn a lot of concepts. Alright. So now let us proceed to third problem. So this actually appeared in IIT JEE 2009. Alright. So let us go through the question. The center of two circles C1 and C2, each of unit radius, are at a distance 6 units from each other. So you have two circles. So this is one circle and this is another circle. So both has the same radius and the centers are 6 units apart. Let us say this is O1, this is O2. So this length is 1, this length is 1. Alright. So this particular length is 4. So this is what we get from the first sentence. Let P be the midpoint of the line segment joining the centers of circles C1 and C2. So P lies somewhere here. Alright. So P is the midpoint. So P lies somewhere here. Now let us go ahead and C be the circle touching the circle C1 and C2 externally. So there is a circle that touches C1 and C2 externally. So both of them. So let us draw the circle C. So let us say the circle looks something like this. It touches both C1 and C2. So let us draw C. Let us say the circle looks something like this. It touches both C1 and C2 externally. Okay, like this. So it touches C1 at this particular point and C2 at this particular point. Now let us move ahead. If a common tangent to C1 and C, there is a common tangent to C1 and C. So this is C1, this is C. Passing through P. So common tangent has to pass through P. So this has to be something like this. all right, is also common tangent to C2 and C. So it should be a common tangent to C2 and C also. So it should touch C2 as well. So the common tangent goes something like this. All right. Now the radius of the circle C is equals to dash. So this radius we have to find out. Understood? Now, since this yellow circle C is touching both the circles, so let us say this is R and this is also R, all right, and this is 1 and this is 1, all right. So let us say this is O. Understood? Let us say this intersection point is A and this intersection point is B. Since C1 and C2 has same radius and P is the midpoint of O1, O2. So there is a perfect symmetry. So we can say PA is equals to PB. All right, PA is equal to PB. So you can prove it also, but since there is perfect symmetry, you can write PA is equals to PB. And what is that length? So we know that AB is the length of direct transverse common tangent for C1, C2. So what is the formula? It is the distance between centers, which is 6 square minus, all right, R1 plus R2 whole square. We have derived it here. So D square minus R1 plus R2 whole square. This is the length of transverse common tangent. 6 square minus R1 plus R2 is 2 whole square. So this is root of 32. So that is simply 4 root 2. So therefore P and PB are each 2 root 2. So now consider this triangle POO1. Since PO1 and PO2 are equal and these two lengths are equal, so this angle has to be 90 degrees. All right. Therefore, we can write PO square plus PO1 square is equal to OO1 square. All right. What is PO square? We don't know. PO square plus what is PO1 square? Since P is the midpoint, this length is 3. All right. O1, O2 is 6. So PO1 is 3 square is equal to OO1 square. OO1 square is simply R plus 1 whole square. All right. Now consider this particular triangle, or sorry, consider this particular triangle. All right. So this is the radius and this is the tangent. So this angle is 90 degrees. Correct? So from that we can write using Pythagoras theorem PA square plus R square is equal to PO square. Alright, we know PA is 2 root 2. So PA square is 8 plus R square is PO square. Now substitute PO square into this equation. 8 plus R square is plus 3 square is R plus 1 whole square. Now this is simply 8 plus 9 is 17 plus R square is equal to R square plus 1 plus 2R. R square will get cancelled. 17 minus 1 is 16. 16 is equals to 2R and R is simply 8. Alright, have you understood how to solve these kind of questions? I hope I'm clear explaining this. So with this we come to the end of episode 5. In the next episode, we will be discussing other concepts of circle such as radical axis and the angle between two circles. Alright, so if you like the content that I'm making, share it with your friends. Subscribe the channel for more such content and do not forget to like the videos. And if you have any queries regarding whatever I've explained in this particular episode, you can reach out to me in the comment section. Also, if you have any generic queries, you can write them down in the comment section. I'll meet you in the next episode. Thank you for watching.